How does that even work?
It's magic. I'm kidding. The beads are moving because of magnetic fields who, like magic, are invisible. Magnetic fields are invisible and they're not stopped by physical barriers. All magnets have a north and a south pole. When two different poles come near each other, they attract each other. But when two of the same pole come near each other, they repel. Now that's the magic behind magnets.
My next trick will be a stunning display of attraction using nothing but a nail, a wire, and electricity.
If there's one thing that gets you boys in high school, it's magic tricks, right?
Well, I do agree, I'm not talking about that type of attraction. I'm talking about creating a temporary magnetic field using nothing but electric current. Electromagnet. See how a magnetic field is created when both ends of the battery are touching the wire.
Oh my god.
See how it disconnects once the electricity is cut off. This is because the magnetic field is only temporary.
But how do you tell which direction it is?
Why, use the right hand rule, of course, the second right hand rule. See which way the current is traveling. Since it always travels from negative to positive, you know that the current is traveling this way. So put your thumb towards the direction of the current and wrap your fingers around the edge. This means that the magnetic field is rotating clockwise around the nail as the fingers are wrapped around it.
That's cool, but that magnet seems pretty weak.
We can make it stronger by changing some types of things about the magnet. For the first part, you can change the material of the solenoid. The best way to make it stronger is to use a soft metal that conducts magnetism, well, like iron or another soft metal. You can also change the number of wraps around the solenoid. The more wraps there are, the stronger the magnet will be. If you really want to make it strong, you can find a wire that's more thinly coated, as this will make the wire closer to the solenoid and have it be stronger, make it stronger.
Yay! We love magic! Now, for my next trick, I will make the compass change directions with no obvious outside force but a wire. Going back. Look at that electric current making a magnetic field.
How do you tell what direction the magnetic field is moving in?
The current moving through the wire is creating a magnetic field, which is creating, or is shown by magnetic field lines coming out from the wire. When there's no current, though, there is no magnetic field.
How do you calculate the force?
There are two easy formulas. To calculate the force on the current moving through a wire, you use the equation force equals current, I, times length of the wire, L, times B, the strength of the magnetic field. But then if you want to calculate the force on a charged particle, you use the formula force equals charge, Q, times velocity, V, times B, the strength of the magnetic field. When the forces are at angles other than perpendicular, you have to add sine theta to both equations, theta being the angle between.
For my next trick, I will make electricity with my own bare hands, sort of.
You can be a superhero.
No thanks, I look much better in a cloak than I do in tights. But anyway, watch this. See? Alright, go ahead.
Go.
Wow. Are you sure you didn't plug it up in an outlet somewhere?
Not. I'm just converting the mechanical energy of turning the crank into electrical energy, which is then put into the motor. Look at how the generator is connected to the positive and negative ends, just like any other power source would be. Like in the motor that I showed you before, the rotating of the crank turns the armature in the motor and in the generator, which creates an electromagnetic field. The loop or the armature is rotated in the electromagnetic field, which creates an electric current. As the loop rotates, the strength and direction of the current changes.
How is this different from a DC motor?
You see, they're very similar but different in some ways. They convert energy in different directions. You see, the generator converts mechanical energy into electrical energy, whereas the motor converts electrical energy into mechanical energy.
Oh, that makes sense now.